speaker is Aaron Calhoun. Aaron.
To begin, I would like everyone to imagine two different scenarios. And as I describe these situations, put yourself there and try to think about the automatic reaction your body would have to the different variables. The first is it's a cool winter's night. You just finished getting ready for bed, and you notice that your window is still open. And right before you close it, a cool breeze rushes in and brushes over the surface of your skin. The second is you're grading my perfect speech paper. And as you turn the page, you get a small paper cut on the tip of your finger. Now, in both these situations, your body had a different reaction. But whether it's a shiver to keep you warm or a slow bleed to close a wound, these reactions can be categorized under something known as homeostasis. Homeostasis is something that's very vital to life. In fact, it's saved everyone's lives in here multiple times. As a nursing student, I find the body fascinating, and my studies over the years has really convinced me that learning more about how the body works is something that should be more understood. In order to better understand homeostasis, let me explain what it is and what it means, and then we'll talk about how all the different parts of the body work together to keep you healthy. Let's start by looking at what it means in relationship to your own body. Mosby's medical dictionary defines it as a relative constancy in the internal environment of the body, naturally maintained by adaptive responses that promote healthy survival. Now, that's a bit of a mouthful. In plain English, that pretty much means a living organism's ability to maintain stable, healthy situations. In her book, Anatomy and Physiology, Elaine Mariette gave credit to this man, Walter Cannon, for coining the term homeostasis. Now, while it directly translates means static or unchanging, the body is dynamic, and everyone knows that different levels within your body will change, whether it's blood temperature, blood sugar, anything like that will change because of variables. And the best example that I have found is that of Benjamin Cummings' seesaw example. The best way to describe it is as long as your body stays within certain boundaries, you will stay happy, healthy, and warm. This is important because we have variables that impact us every single day, whether it's bacteria, temperature, or even physical danger. We need our body to keep up with the changing world around us. It's like I said, it's maintained by many complicated processes within the body, and if a stimulus becomes too strong for our body, we will experience a change, which will not be good. It boils down to, if your body is in balance, you'll be happy, but if not, you'll look like SpongeBob over here. Maintaining homeostasis is so important that the body has to do it automatically. And you can see that this would be very vital because if it wasn't automatic, we'd have to call off of work or school every single day. We got a paper cut to make sure that it healed correctly. Now that we know why we need homeostasis, let's look at actually how the body does it. The entire process of keeping the body stable is known as the homeostatic control system. And it has 5 different parts and 5 different steps. And no matter which part or component is involved, each one can be assigned to one of these steps, whether it's the receptor, afferent or efferent pathway, control center, or effector. These are all going to be working together to promote balance within your body. Now, the response that your body can have can be one of two. It can either be a negative feedback response or a positive feedback. Now, that's not saying good or bad. It's saying whether it's working with the stimulus, like your blood, or working against the stimulus, which would be a shiver to keep you warm. Positive feedbacks are the most rare because most time the stimulus is going to be something that's going to be bad. This is the seesaw model that Benjamin Cummings came up with, and there's a lot of parts and a lot of explanations with it, but the simplest way to describe it would be through this. If we have a stimulus, let's say it's an increase in temperature, the receptor or sensor to that is going to be your entire body, because chances are not just your finger is going to get hot at once. Then the information from that change or from your receptor is going to travel along the afferent pathway. That information is going to go to your brain or the control center. Your brain is going to make a decision. It's going to send that information down the efferent pathway to the appropriate organ. In this case, it would be your skin. To keep cool, you need to start sweating. Now, like I said, each one of these steps can be replaced with numerous different numbers of body organs or body systems. But the whole idea of it is to maintain stable internal conditions. Obviously, we're going to want our body to do something if there's a gaping hole in our side. To summarize, homeostasis is a constantly occurring process that keeps us from turning into bedridden sponges, quite frankly. Whether it's a small healing paper cut or a high temperature, each response from your body to protect you has more going on than we could ever see from the surface. If you'd like information on homeostasis or any body system for that matter, recommend talking to a science professor or even taking a science course here at Northampton. After this, I hope you'll never look at a scab or sugar the same way again.